Hello, this video is about inverse functions. When we solved our equations and inequalities, we used inverse functions. So what are they and how do we find them? Well, first of all, they have to be functions. And in order for something to be a function, they must pass the vertical line test. And the vertical line test says that any vertical line should cross our graph at most once. Then we have a function. So if we have some kind of a function, some kind of expression, and we make a sketch of it, so let's say here is y equals x to the 2. We know what they look like. These are quadratics. They look like a U shape. So we would get something that looks like this. And if we imagine drawing vertical lines anywhere on that picture, any vertical line we can imagine will only cross our graph once, no matter where we make the vertical line. So this is a graph of a function. Now, in order for something to have inverse, it has to be a function, but it also has to pass horizontal line test. And the horizontal line test is exactly like the vertical line test, only this time we draw horizontal lines instead. So the horizontal line test says that any horizontal line should cross our graph at most once. And then, if that happens, then we have what's known as 1-to-1 function. And any 1-to-1 function has inverse. So any 1-to-1, that's how we write it, 1-1. Any 1-to-1 function, let's back up. Function has inverse. Alright, so now let's see how to find the inverse. In order for us to find the inverse, there is a two-step process. Step 1, switch the x and the y, which means we switch the input and the output. Second, we solve for the y. So let us use this process to find the inverse of a linear function. So here is example. Let's say find inverse of f of x is 2x plus 1. So step 1, we switch the x and the y. Well, where is the y? The f of x, g of x, h of x, all of these names, they are just different names for the y. So first of all, we have y equals 2x plus 1. So step 1 would be to switch the x's and y's, and then we're going to get x equals 2y plus 1. Step 2 is now we solve for the y, which means we undo everything that is on the same side with the y, and we're going to get y by itself. So to do this, we undo plus 1 by minusing 1 from both sides, and then to undo multiplication, we divide everything through by 2, so we have x minus 1, and we divide each by 2, and that will be the answer to our inverse function. Now the inverse is abbreviated with the same name as the original, but instead we also add the -1. So it's f to the power -1 of x is x over 2 minus half. And that's the final answer to how to find the inverse. Switch x and y and solve again for the y. Now the inverse functions have a very interesting property that if we let's look at them on a calculator and we'll see what that property is. So we will make a sketch of the original with the inverse and we'll notice what they have in common. So here is the, let's type in the original, 2x plus 1, and then let's type in the inverse, x divided by 2 minus half. And let's look at a picture. So here comes original, here comes the inverse, and the relationship they have between each other is that if we draw the line y equals x, so let's add that here as the third, there is the x. If we imagine visually folding our graph along the line y equals x, the green line, then the blue is going to be on the red and this blue is going to be on the red. So these lines are mirror images of each other if we fold our graph on the line y equals x. And every single inverse has that property. If we draw line y equals x, the original and the inverse will be the mirror images of each other. Now we cannot use the picture to prove that the two functions are inverses of each other. Sometimes we may be given on a quiz or the test the two different functions and asked, are these inverses? And just making a picture and looking at it is not enough. We have to show that they are inverses. Now the line we just drew is y equals x. And that's exactly what happens if we use both of the original and the inverse function together. If we substitute one inside another, they both will cancel each other off and just give us x. So if we picture ourselves plugging the blue function into the red, they're both the same distance away from the green. They will cancel each other off and land on the green and will give us y equals x. And that's how we prove that two functions are inverses. So to show, if the question says show or prove that the two functions are inverses, show that x over 2 minus half is inverse of 2x plus 1, what needs to happen is we have to substitute one inside of another. So if we look at our original, and each time we see x, we substitute our inverse, what are we going to get? Well, we're going to get 2 times x over 2 minus half, and then there is plus 1 at the end. So if we simplify it, what do we get? 2 times x over 2 is just x. 2 times negative half is negative 1. Plus 1, 1 negative 1 cancels, we get equals to x. And this is a proof that the two functions are indeed inverses of each other. And that's how to find the inverse and how to prove that the two things are inverses of each other. Not everything has an inverse, and it's important before we apply the inverse, it's important to be sure that whatever we are applying the inverse to actually is one-to-one and actually does happen to be a function and also one-to-one function. Then it has an inverse. And that's it for this video. If you have any questions, please let me know. Thanks for your time. Take care.